Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over problems 30 to 34 of the Geometry Common Core Regents exam for January 2017. If you need access to other subjects, Algebra 1 or Algebra 2, Common Core, just take a look at the link in the description below or go to Mathgotserved.com and you'll find access to all those tutorials. Alright, let's take a look at question 30. It reads, in the diagram below of isosceles triangle ABC, side AB is congruent to side CB, and angle bisectors AD, BF, and CE are drawn and intersect at X. Question, if measure of angle BAC is 50 degrees, find the measure of angle AXC. Alright, so to get started, we're going to make use of the fact that this triangle is an isosceles triangle as stated here. So basically AB and CB are going to be congruent. Okay. Now what do you know about the base angles of an isosceles triangle? If this is an isosceles triangle where CB is congruent to AB, then these two base angles are going to be congruent. Angle A is going to be congruent to angle C. Okay? Alright, so let's go ahead and write it down. Since triangle ABC is an isosceles triangle, the measure of angle BAC is going to be equal to what? Is going to be equal to the measure of angle BCA. Those are the base angles of our isosceles triangle. Okay. Now, why are we focusing our attention on those two angles? Well, what we know is that the measure of one of the base angles BAC is 50 degrees. Okay. So if the measure of angle BAC is 50 degrees, what is the measure of angle BCA? Let's write it down. If the measure of angle BAC is equal to 50 degrees, then what? Then the measure of angle BCA is also 50 degrees. That's the base angle of a isosceles triangle. Okay. Now we know that we have some angle bisectors, and what do angle bisectors do? They break angles into congruent parts. Okay, so what's going to happen is that AD is going to bisect this 50 degrees into two equal parts, and EC will bisect this angle into two equal parts. So we'll basically have 25 degrees on the top, 25 degrees on the bottom, 25 degrees here, and 25 degrees here. Okay, so basically we have the measure of angle BAD is equal to what? Is equal to the measure of angle DAC, and that's equal to 25 degrees. And we can also say that the measure of angle BCE right here is equal to what? The measure of angle ECA, and they're both equal to 25 degrees. Alright, we can arrive at this conclusion because segments or side AD and CE are what? Are angle bisectors. That is what angle bisectors do. They divide angles into two equal halves. Okay? Alright, now let's go ahead and focus on triangle AXC. Okay, so let's write that down. In triangle AXC, so for triangle AXC, this is what we're focusing on right here, just this portion right here, that triangle. In triangle AXC, what is the sum of the angles in a triangle? So what is the sum of this angle right here, this 25-degree angle right here, this angle right here, and this angle right here? What's the sum going to be? What's the sum of angles in a triangle? It's 180 degrees, right? So the measure of angle AXC, which is the third side, is going to be the sum of all the three angles, 180, minus the sum of the other two angles, 25 plus 25. Okay? And then you have 180 minus 50. And your final answer is 130 degrees. That is the measure of angle AXC. So measure of angle AXC is equal to 130 degrees. All right, let's take a look at question 31. It reads, in square GEOM, like geometry, in square GEOM, the coordinates of G are 2, -2, and the coordinates of O are -4, 2. Determine and state the coordinates of vertices E and M. Now we're going to use this grid right here to help us to solve this problem. There are other ways you could do it too using arithmetic, but it's faster to do this graphically, okay? Alright, let's start by graphing the coordinates that are given. G is 2, -2, 1, 2, and -2 right here. That's the coordinates of vertex G. And then the next vertex that we know is 4, -4, 2. So we have 1, 2, 3, 4, 1, 2. This is O. The square is GEOM. So based on the order, we can easily tell that G and O are they're opposite each other. Okay, so GO is basically one of the diagonals of the square. Okay. Now, what do we know about diagonals of squares? Let's write this down. It's a point to note. The diagonals of squares they are always what? They are perpendicular. That's one thing. And they're congruent. Okay. Okay, so what we're going to do is we're going to find the midpoint of OG because the diagonals intersect at the midpoint, and then we're going to take advantage of the fact that they're perpendicular to construct the second diagonal for the square. Okay, so let's find the midpoint of OG. So find the midpoint of diagonal OG. Okay, because the other diagonal will go through there. So the midpoint of OG is going to be, using the midpoint formula, you add the x's. So this is x1, y1, x1, x2, you add them. So it's going to be -4 plus 2 divided by 2. And then the y's, this is y1, y2. You add them and divide by 2. Okay. If you do your calculations, you have -4 plus 2 is -2. Over 2 is -1. 2 plus -2 is 2 minus 2, which is 0, over 2, which is just 0. So the midpoint is -1, 0, which is right here. Okay? Okay. Another way that you would have, if you wanted to find a midpoint, M, is you just do the slope triangle. So you rise 1, 2, 3, 4, and go back 1, 2, 3, 4, 5, 6. And you do the half of the rise and half of the run to take you to the midpoint. Alright, so what's the slope of this diagonal right here, OG? What's the slope? So the slope of OG is basically the rise over run. So we're going to go 1, 2, 3, 4, So you go down 4 and over 1, 2, 3, 4, 5, 6. Or you can go 1, 2 and over 1, 2, 3. Okay? So you rise -2 and you run 3. Okay? Now guess what? The slope of the other diagonal, GM, no, not GM, the other diagonal we have OG, so EM, the slope of EM is going to be the negative reciprocal of this. So it's going to be negative reciprocal of the slope of the diagonal that we have right here. The negative reciprocal of -2/3 is simply 3 over 2. Alrighty? So if I want to go from the center to any of the vertices, E or M, I just use 3 over 2. So if I want to find vertex, so we have G, E, M. If I want to find E, I'll just start from here. I'll rise 3, 1, 2, 3, and go over 1, 2. That's one vertex. Okay? Rising 3 and going over 2 is the same thing as going down 3 and backing up 2. So if I want to find the last vertex, I'll go down 1, 2, 3, and back up 1, 2. Bam. Okay, so we have G, E, O, M. Okay, so there goes our vertices. Okay, so let me join the square, and then we're going to write down the vertices, okay, of M and E, and we'll be done. So there goes the square right there. It's like this has been rotated a little bit. Okay, now vertex E. What are the coordinates of vertex E? Coordinates of vertex E are 1, 1, 2, 3. So 1, 3 for vertex E. And then for vertex M, the coordinates are 1, 2, 3, 1, 2, 3. So it's -3, -3 for the X and the Y coordinates. So this is just one way of finding the coordinates of the vertex of the vertices of a square using the graphical approach. Alright, let's take a look at 32. It reads, triangle QRS is graphed on a set of axes below. On the same set of axes, graph and label triangle Q prime R prime S prime the image of QRS after dilation with a scale factor of 3 over 2 centered at the origin. Okay, this is going to be really easy because the dilation is centered at the origin, so it's very straightforward. All we just have to do is apply the scale factor to our coordinates and we are good to go. Okay, so let's start with point R. Point R is going to be, let's see, R is 2, 0. So R prime, since we have a dilation of 3 over 2, centered at the origin, you just compute 3/2 of this coordinate right here, and it's going to be 3, 0. You just distribute this 3/2 into this number right here, and then you get 3, 0. Okay, and then we have point Q is 1, 2, 1, 2, -2, 2. So Q prime, dilating by a factor of 3 over 2 of -2, 2, just distributes 3 over 2 across. The 2's cancel out, you have -3, 3. And then the last one is point S. Point S is 1, 2, 3, 4. 4, 1, 2, 3, 4, 5, 6. 4, 6. So to get point S prime, we'll dilate by a factor of 3/2, centered at the origin. Okay, when we distribute, we are going to have 2 goes there, 2 times 3, 6. 2 goes there, 3, 3 times 3, 9. So 6, 9. Okay, so let's go ahead and we are asked to graph it on the same axis. So let's go ahead and do that. I'm going to make it blue, okay? So R prime is 3, 0, right there. That's R prime. Q prime is negative 3, 3. 1, 2, 3, 1, 2, 3. That's Q prime. And then S prime is 6, 9. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. Right there is point S prime. Okay, so let's go ahead and draw the dilated rectangle. After dilation by a factor of 3 over 2, centered at the origin. And this is our final result. Okay? Alright, we have a second part. The question is, use slopes to explain why Q prime, why side Q prime R prime is parallel to side QR. Okay? So this is our explanation here. It has to do with what happens to the slopes of sides of an object upon dilation. Okay? So dilation does what? Two slopes. Dilation preserves the slopes of corresponding sides of a triangle upon, yeah. So dilation preserves the slopes of corresponding sides of a triangle. Okay? So what does that? What can we conclude from that? Since we have two sides that are corresponding, so QR corresponds with Q prime R prime. So since side QR and side Q prime R prime are corresponding sides, they have what? They have the same slope. Same slope, which means that they are parallel. Okay, which means that QR, side QR is parallel to side Q prime R prime. Okay? Alright, let's take a look at question 33. It reads, using a compass and straight edge, construct a regular hexagon inscribed in the circle O below. Label it A, B, C, D, E, F, and leave all construction marks. Okay. Alright, so first things first, what we're going to do is basically just draw the radius of the circle. Alright, so there goes the radius. What we want is we want to use this measure to basically split up the circumference. Okay? So this radius basically splits this circle into 6 congruent lengths. When we connect adjacent points of intersection, we will end up with a hexagon that's inscribed nicely inside this circle. Okay? Alright, so let's start by taking our measurement. So from the center, we're going to measure the length of the radius. That's what we want right there. Okay. So let me make my markings blue so you can see them. Okay. All right. So there you have it. So we have that measurement right there. So what we have now is the length of the radius. So now I'm going to start splitting the circumference using that radius length. Is going to split up the circumference into 6 equal halves. You'll see that in a second. So there goes my first piece right here. Bam. To get my next piece, I will just simply place the pointed side here, and then C. Mark it. Second one. Let's find the next one. Just right here. You see how it's almost half the circle now? Okay, let's keep on going. Next one. You don't even have to keep track of how much you've done, because at the end you end up exactly where you started if you do it correctly. Okay, try to line up the points perfectly. So this intersects right here, and then what do you see happening? Intersects right back where we started. Excellent. So there you go. So using the radius, we basically split the circle into 6 congruent arc lengths. Alright, so if we draw the chords connecting adjacent points of intersection, that will give us our final answer. So let me put this in green. So if I go from here to here, that's first side of my inscribed hexagon, second side, third side of my inscribed hexagon, fourth side, fifth side, and there goes the sixth side. Alright, almost done. We were instructed to label the hexagon. How are we going to label it? Let's call it A, B, C, D, E, F. That's what we're instructed to do. A, B, C, D, E, F. Okay, this is not just for fun. There's another question that we are supposed to answer using these labels, okay? Alright, let's look at the second part. It says, if chords FB and FC are drawn, which type of triangle, according to its angles, would triangle FBC be? Explain your answer. Okay, so let's go ahead and give ourselves a visual so we know exactly what the question is talking about. So triangle FBC is created by drawing chords FB. So we connect these two. Let me make it purple. So FB. Oh, snap. Let's try that again. So we have FB and FC. Notice what happens while we're drawing FC. Bam! It goes right through the center of the hexagon. So we have an inscribed triangle, and one of the sides of the inscribed triangle is the diameter. So what do you recall a theorem about that? It's called Thales theorem, which basically says that if you inscribe a triangle in a circle and one of the sides is a diameter, then you have a right triangle. That's what Thales theorem says. Okay, so let's go ahead and write it down. We're gonna answer the question first. Triangle FBC is a right triangle. Okay, remember we were asked to classify the type of triangle that triangle FBC is. So it is a right triangle. How do we know? Because it's due to Thales theorem. Okay, this is because this is the explanation piece. If a triangle is inscribed in a circle, just like triangle FBC, okay, in a circle, such that one of the sides is the diameter, or overlaps the diameter, is the diameter of the circle, then that triangle is a right triangle. Okay, so that's basically what Thayle's theorem says. So in triangle FBC, which is inscribed, what did we find out? FC is the diameter. Okay, FC is the diameter. Okay, that is why triangle FBC is a right triangle. Okay, is a right triangle. So that's basically why we have the classification. Okay, let's take a look at 34. It reads, a candle maker uses a mold to make candles like the one shown below. Okay, so we have a interesting looking candle here. The height of the candle is 13 centimeters and the circumference of the candle at its widest measure is 31.416. Use modeling to approximate how much wax to the nearest cubic centimeter is needed to make this candle. Justify your answer. Okay, so what on earth are we going to use to model this candle? We are going to use a cone. Okay, so let's write that down. We will use a cone to model the candle. Okay. All right. And another thing to note is that the circumference at the base is the widest measure. Okay, because it says the circumference is widest at 31.4. So the circumference of the candle is widest at the base. Okay, is widest at its base. Okay, so let's give ourselves a little visual here. We're just gonna sketch it so everyone knows exactly what I'm talking about. So there goes the base. That's where the circumference is the widest. It shrinks until the peak where it's actually 0. Okay. All right. So there you go. Okay. Now, what are the formulas that we're going to use here? We're looking at how much candle wax is used, so how much fills the interior of this cone. That's what we're looking at, and that is volume. Okay, so formulas coming up. First one is volume of a cone, which is a third of the volume of a cylinder with identical height and base radius, 1/3 pi r square h. Okay, so let's put in our measures here. So this is the height of the triangle. Okay, so this is the height h, and then we also need the base radius. Okay, so let me change the color here. Let's make it green. Alright, so there goes the base radius. Okay, so the h and the r in the formulas here, this are their values. Okay, alright, let's get started. So we want to find the volume. Okay, so volume first. So we're going to use this formula. Oh wait, there's another formula that we need, which is the circumference formula. Circumference of the base is 2 pi r. Okay, so let's do the volume first. So we have V is equal to 1/3 pi r square. H, we need r and h to compute this. H, the height is provided for us, is 31.416 right here. So let's put it in. It's 31.416. What's the radius? Ladies and gentlemen, we do not know what the radius is. Okay, so before we do that, real quick correction, I confused the circumference of the base with the height, so let's fix that real quick. The height is 13. Okay, sorry about that. Height is 13. And the radius is a mystery. We do not know what the radius is. So what's going to help us to figure that out? Well, we have a clue, which is the fact that the circumference of the base is 31.416. So the distance around this base is 31.416. And a component in computing the circumference of the base is a radius. Okay, so we're now going to use the second formula to find what r is. So let's write that down. Find r first. So we're going to use the fact that c is equal to 31.416 to find that missing component for our volume formula. Okay, don't forget c is equal to 2 pi r. That's what relates to circumference and the radius. We're going to substitute 31.416 for c. Is equal to 2 pi over r. And then we're going to solve for r, okay? To do that, we'll divide both sides by 2 pi. 2 pi, 2 pi. Plug that into your calculator. You have r equals 5.000 something else, but that's good enough. Alright, now we have the missing piece. We can now compute the volume. Okay, so the volume again, 1/3 pi r square h. I wrote it again so you can see exactly what's going where. So r is 5, so 5 squared times the height h, which is 13. Okay, just simply let's plug this into our calculators and see what we get. Okay, where's my calculator? Alright, I'm having some issues with my other calculator, so I will just use this one. 1 divided by 3 pi times 5 squared is just 25 times 13 is an approximate answer, 340 to the nearest cubic centimeter. So V is equal to 340 centimeter cube. That's how much wax can be used to create that candle that we modeled with the cone. Alright, so that's that. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments, just ask it in the comment section below, and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other tutorials such as this. If you need access to other Regents content, you can go to Mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.